We'll go through this pretty quick because it's just a review, stuff that we've already done. Reminder that your zeros are the x-intercepts of your graph, and they are also called your roots, as well as your solutions. Alright, the polynomial has, so whatever the degree is, that's how many n zeros we could have. So if it's degree 2, it would have 2, 3, 3, 4, 4, and so on. If it is in even degree, it's going to have an even number of roots, or real roots, and then an odd degree of polynomials, or the polynomial would give you an odd number of zeros. Alright, the solutions to those equations are going to give you, are found when we set f of x equal to 0. That will give you, otherwise known as roots. Alright, so then what they're talking about here with this c is, well, remember when we're still in the parentheses, we have this x minus c, or when it's in its factored form, and those become linear factors, because what we're going to be doing later, here pretty soon, is we're going to take the solutions and we're going to put them back into factors to then go write the equation into its standard form. So we're going to go backwards. Instead of factoring them out and finding the zeros, we're going to use the zeros to find the actual equation. So here, if we were looking at what are the linear factors, first thing we've got to do is take out your x. So leave you with x squared plus 5x minus 24. And then when we factor that out the rest of the way, looks like we would have x plus 6, no, x plus 8, and x minus 3. So those would be, these three things would be your linear factors. Y'all remember that from algebra 2? Okay, alright, and so then of course it asks for the zeros, so this one would be 0, that one would be negative 8, and this one would be 3. Okay, there. Alright, so I'm not going to work very many of these just because y'all know how to factor. So, what do y'all think? What do you want me to work on 1 through 4? Any of those, or y'all are okay? Tell me what you want, and I'll do it. 3 or 2? 3? 3? Okay. So if you remember, because this is x to the fourth and this is x squared, I can factor it the way I would a quadratic. It would just, this would be x squared and this would be x squared. Y'all okay there? And then looks like both negative, so minus 1 minus 4. And both of those are a difference of squares. So you can either factor that, or you can take each of those and set them equal to 0, however you want to do it. I'd probably write it like this. And then take the square root of both sides. It's a bit faster. So then we would have x is equal to plus or minus 1 and plus or minus 2 there. Okay, on that one. 4 we have to slip and slide. So the process would be similar. We'd multiply that back. So we have x to the 4th minus 37x squared plus 36. So then I can split it. X squared. Looks like both minus, so 36 and 1. Same thing. There, except for I've got to take that 9 back out. So I would go ahead and pull your 9 out right here. Okay on that? So then this would give me x squared equals 4 for this one. And then this would give me x squared is equal to 1 over 9. And then I would take the square root of both sides. So x would be plus or minus 2 and then plus or minus 1/3. Y'all okay on those? And 2 up there was kind of similar to the one that we worked in the example, which you take the x out first and then you split it. Same thing with 1. Good there? Okay. So we'll look at factoring by grouping, which is where we're going to split it in half down the center. So when we have 4 terms, we usually do grouping. So we'll cut it here. And I would take out my GCF here, which would be x squared, which would leave you with x plus 5. And then this one, I would have to take out a negative 9, so that this would also be x plus 5, because we need those to match. So then this becomes its own, x squared minus 9 times x plus 5. So then this one will be x squared equals 9 squared both sides, that's negative 5. So x is plus or minus 3 and negative 5 there. Y'all okay? You we did grouping earlier this year already? Okay. Everybody comfortable on grouping? Okay. Alright, so now we're gonna kind of talk about multiplicity a little bit, just meaning that if my same factor happens more than once, rather than writing it multiple times, you would draw multiplicity of whatever it was. So here, if we take out the x, that's gonna leave us x squared plus 10x plus 25, which factors to be plus 5 and plus 5. So then this is 0, that's negative 5 and negative 5. So we would have x is equal to negative 5. And typically they would want you to write out like multiplicity of 2. I'm not going to do that. I'm just going to let you write m2 to save you some space. And then 0. Y'all okay with that? Rather than have to write out the multiplicity. Let's see. On this one, I'd probably take out a negative x squared, which would leave you x squared plus 6x minus 9. And that's going to be, looks like plus 9, sorry. Minus 6x, those signs change. So minus 3, minus 3. So this has 0 twice because it's x squared. You all okay with that? And that's positive 3 and positive 3. So you would have x is equal to 0, m2, and 3. Multiplicity of 2. Questions on that one at all? Okay. When we're graphing, if we graph this is a cubic, so it's going to do something like that. I don't know exactly what it looks like. So I'm going to go ahead and factor it here. So x, let's see, that would be the x squared plus 4x plus 4. So plus 2 and plus 2. I'd probably write it this way. So then I would have 0, negative 2, multiplicity of 2. Y'all okay there? Alright, if you graph this, I don't know exactly, but I know I have a negative 2, and I have a 0. And I know its overall shape is like this. So what that tells me, because this would be where negative 2 is, and this would be where 0 is. Y'all okay there? So what that, well, that's not really what that'd be where we go through, but that tells me that I'm going to come up and come back down. I don't know where this goes down, but I know it's going to do that. That is not a complete accurate graph by any means. But when it has an even multiplicity, that means it bounces there. When it goes through, that means it literally goes, it goes through. It only happens an odd number of times. Are y'all okay with that? Did we do that now, Commissioner? Okay, so if it's an even multiplicity, then it is tangent to the axis line. I usually let y'all use the term bounce. It bounces at the axis line. If it has a multiplicity that is odd, then it intersects or goes through. That makes sense to y'all? Okay. Alright, so if we looked at this one right here, this would be, the solution here would be 1, the solution here would be 3 halves, and the solution here would be negative 4. So negative 4 happens one time, which means on the graph it's going to intersect. Okay there? What about 1? What's its multiplicity? 2. So what's it going to be? Intersect or tangent? It's going to be tangent. No, I said I'm going to round down.